Next, we want to prepare. The second objective is that we want to prepare a proper product. Either it might be by any means we are going to be using, right? We want to make a proper product that can be used, that can be further used after once you see. When we are taking waste management process, we want to make that whatever waste which can be recycled, right? Those wastes can be taken up to the proper condition. That means that the purpose of recycling can be achieved. Apart from this, we want to make sure that whatever the byproducts or the refined products which are going to be getting once we go for incineration or energy recovery by burning the waste in the incinerator, if you are getting a heat energy, then the heat energy is converted into some means of energy. That is what you are going to be using. Then the composition of biogas production, which you are going to be using by decomposing sanitary waste or waste which is generated from a kitchen, right? We are going to be using we are going to be generating a biogas production, right? So we want to make sure that whatever these products which can be established, right, from different what you call it as recycling and reuse process, we have to make sure of that one, right? That is our second objective. And the third objective of doing this one is that we want to minimize the cost. The cost which you are going to be getting, that cost has to be minimized. That means that, as I told you earlier, once if you are taking a product, right, if this is a waste, right, if this is waste is formed by some xyz product, let us say this waste is comprised only of a paper, right, paper or a waste paper, right? Once this waste is being recycled, what happens, the area or the portion of fill or the disposal area which is required is going to be getting reduced. Apart from that, the new paper or the raw material required for producing the paper is going to be getting decreased. So in two ways we are going to be affecting if we have a proper recycling and recovery process. To overcome this, this is only possible if your component segregation is going to be different. Component segregation, again, as I told you, if you have what you call it as your waste, this waste might be comprised of any type of components, right? Those components might be, some might be plastic, some portion might be with respect to metal, right? See, this I'm repeatedly telling so that you have to have a clear understanding, right? uh, right, because if you have this, if you have any doubt, again, it is not going to be getting into this one. Or let us say this is a sanitary waste, right? So what happens, this component comprises of different component, this waste comprises of different components. So what we want to make sure that all these components are going to be separated thoroughly. Why we want to separate them thoroughly? Because we want to make sure that the materials which can be recycled or the components which can be recycled or which can be used, like if you have a sanitary material, it can be used, or sanitary waste if you have, those can be used for biogas production or biogas plants, fruits and whatever you are going to be getting, that can be easily processed or taken. Whereas if you have plastic, it can be recycled. Whereas you have metal, it can be reused. See, there is a difference between recycling and reuse. Reuse means once again you are using this one. Recycling means you are forming a new product, right? So like this, we are going to be making sure that the recycling process or reuse process can be done. So for that reason, or to achieve this one, your component separation plays a very important role. So based upon this, we have different type of component segregation, component separations which are going to be taking, right? The first one is what you're going to be doing with the air separation. The second one is your magnetic separation. The third one is screening, and the last one is going to be the floating. So we are going to be taking one by one in detail, because component segregation is a very crucial point in the what you call it as solid waste management system, right? So this technique has been used in for a number of years in the industries which operates segregation of various components, basically from the dry mix. See, what it means to say that, see, as I told you earlier, in India or in developing countries like India, we don't have a proper waste management system. But developed countries, they are going to be having very prescribed flow chart, what we have seen in the previous classes of management system. So they have, right, they have n number of years of experience for using this method for segregation of various components or different segregation, because those are going to be leading to reduction in the what you call it as load of your solid management schemes or solid management system. For that reason, the techniques are going to be used, these different methods are going to be used, right? Especially when you have what you call it as air separation method. This method is used precisely for a material which are going to be lighter in weight, usually organic matters, right? Usually the air separation method is usually used for organic method which are lighter in material or lighter in weight from heavier which are inorganic. See, always remember that in solid waste management, when you have a waste which comprises of organic material is going to be lighter in weight, whereas inorganic material is going to be heavier in weight. See, inorganic material is going to be getting decomposed and all. So we have to make sure that whatever the waste which we are taking, the waste which is going to be separated from this method is only the organic waste, right? Okay. Then the lighter material, as we know that the lighter material might be in a form of plastic, in a form of paper or a paper products or any other organic material. So what do you mean by these waste? See, you might be having small bottles, you may be having polythene bags or plastic bags, carry bags, which you use for buying the vegetables or different components from the market. So those are going to be made up of plastic, right? Then papers, either it may be used paper, rough paper, or a newspaper, or any type of paper, or it might be a paper products. Paper products means what? Like you have tissue papers, right? You have packaging papers, glass, plates, all things comes in the paper products. What all the paper products which are there, those all are in light in weight. See, remember, when we are talking about light in weight, see, if you're taking a waste, right? Let us say this waste comprises of only two components. One is plastic and one is the waste which is from the vegetable and the fruits. That is organic waste which you have. See what happens when you comprise, when these materials are not separated properly or not segregated properly, what happens? This, what you call it as, the wet waste is going to be contaminating the paper or spoiling the property of the paper for recycling process. So at the very instant point, you're gonna be going for separation. See, if let us say a waste is being generated from a college, from our college a waste is being generated, we don't have, or in many systems we don't have a dustbin wherein which you have separate chambers or separate dustbin, one for paper which is going to be dry and one for the other wet waste. No, but what we do, both we are going to be dumping in one container only, both we are going to be dumping in one waste container or dustbin container only. So because of which what happens, the paper which can be easily separated and recycled gets in contact with your wet waste and it is going to be losing the reproductivity or recycling property, and a proper separation has to be done. If that has not been taken place, then you have to go for air separation. In this air separation, we are going to be removing our plastic, papers and paper products and also the other organic matters which are going to be present in the waste. So as I showed, we have seen this is going to be the mechanical separators which are going to be using, when in which the waste is being dumped. From this point, the waste is being dumped as a hopper into the given machine. The given waste is dumped over here. As it is going to be falling, right? Air is going to be blowing. This rotary airlock system, right? The air segregation of the air is there. Then we are going to be blowing the air, right? We are going to be blowing the air. Because of this turbine, the air is being blown. So when it is going to be falling, the air makes a compression. This is an adjustable throat based upon the dimension. This is the adjustable throat. So based upon the dimension of your waist, can be moved forward and backward. So when the waste is going to be dumped over here, this turbine is or this rotatory blades are going to be generating the wings, right? This is going to be in the chamber, the wings, the air pressure is going to be generated. Since it is the waste, as the waste come over here, the heavier waste is going to be getting dumped over here. You have a lock. So since the air is generated at this point, it doesn't have any exit point. This throat is closed. It doesn't have any exit point. So what happens? The air makes a pressure, right, to exit the chamber. So what it does, while it is going to be trying to exit the chamber, it takes along with it the lighter material or lighter organic waste which are going to be there. It is going to be getting removed up from the cyclone or from the chambers, from the exit chambers, whereas the heavier materials are going to be removed up from the bottom. This is how your air separation is going to be done by separating. So this by basically either you can use air or you can use a steam also, right? A steam air stream by air streams are used. The jet of air streams can be used, which is going to be separating the what you call it as materials, the lighter material and the heavier material. So as I told you, the working principle. So the both the lighter material and the heavier materials are going to be segregated. That's what the explanation you have. So lighter components are going to be raised up, or it are going to, because of the air pressure, they are going to be raised up and they are going to be removed from the bottom, whereas the material which are heavier in weight are going to be staying at the bottom. So this, from this exit chamber, they are going to be removed off. The lighter materials are used with and without the further size reductions as a fuel in incineration or as a composite material. Now, see, here you might be having some products of paper, some byproduct paper products, some plastic. So what you do, either you can go for recycling or either you can go for reusing them as a fuel. Both can be done, because see, in incineration, if I'm burning some wet waste, right, this wet waste requires some fuel, right? If I'm burning something over here in incineration, it do require some fuel, right? If I'm using for burning some other fuel, wood and other things, then I'm going to be putting extra economy on my management system. So what I'll do, I'll segregate the lighter material over here, and these materials are again used for burning in incineration. Or if not, if you don't have incineration properties or incineration method over there, you are going to be making them up byproducts, or any other products can be made from the materials which are going to be segregated, right? Okay. Then you have the magnetic pulley. See, this magnetic segregation is important, right? In two conditions, right? Whether you are going to be doing that when you have the existing waste, right? For example, if you have a waste, in the waste, if, as I told you, it comprises of many different components. If you have the waste which is having certain metals which have some alloy property, or which you have some magnetic property, or your ferrous materials are there in the waste, so it do have some reusable property, right? We have a recycling and reuse value of this material. Simply with this, along this material, you cannot dump this waste, right? So I want to segregate them. So I can be segregating them in a raw form, or this waste is taken into incineration, right? Where I'm going to be burning them along with other waste. Once it is going to be burned off, the ash is going to be remain, right? The other waste is going to be converted in the ash along with the metals. At that time, I'm going to be segregating the metal out of the ash so that it can be easily reused. So how do we do this? Right? It consists of a drum type of container which is permanently attached. You have a magnetic. Hence, we say that it is a ferrous material. It do have some magnetic property. So, permanent magnets and electromagnetics are attached to the conveyor belt, which is going to be transferring the waste, or which is going to be separating the waste from the metals, right? So, by using these methods, we are going to be using this one. The conveyor belt conforms to the round-shaped magnetic. Okay, just a moment. Right, this is one. Right. You have basically two different methods, wherein which one you have a stationary and when we have what do you call it, as segregators or a pulleys. So in the pulley system, what we are going to be doing in a magnetic pulley system, here you can see that you have a pulley. This pulley is having a magnet which or electromagnetic which is going to be attached to this pulley. So how we do this one? Once the okay, you first understand this machinery, right? Okay, just a minute. You have a conveyor belt. You have a belt, right? You have a belt. Over this belt, you have two pulleys which are attached at two ends, on which the conveyor belt is going to be rotating. At one end, you have a normal pulley. At the other end, you are going to be having a pulley which is going to be attached with a magnetic, stationary magnetic system, right? Okay. When the waste is going to be rolled, let us say you have taken the wet waste or you have taken the waste which is burned in the incinerator, right? Once it is burned, the complete waste is made to fall on the conveyor belt. Once it is going to be fall, it is going to be rolling, right? It was at this point, now it goes on getting rolling. The moment it comes, right? The moment it comes near to the pulley, it is going to be getting attached, right? Because of the magnetic property. So it is going to be conveyed and brought to the downward sides with a separator, with the separate chambers are going to be there, on which it is going to be removed. So what happens until this point, the pulley has a magnetic property. So at this point, the magnetic waste is going to be attached. Once it is going to be going away from the magnetic area, it is going to be getting fall down, right? So like this, the separation of the metal is going to be done by putting a conveyor belt which conforms to the rounder shape of the magnetic drum. The magnet forces the ferrous materials to fall away from the other waste, right? So by this method, the suppression of, or the mechanical suppression of what you call it as, our waste is going to be taking up, which is going to be with respect to the pulley. Then you have the other method in which, okay, you have the suspended method, suspended, just a moment, right? Okay, you have the other technique wherein which you have a suspended mechanism or suspended magnet which is going to be attached, right? So what it does, the same concept is there, but what we do, we don't, in this mechanism, we don't provide other pulleys, right? We don't provide a separate pulleys. The pulleys is not going to be rotating. It is going to be stagnating at one point only, at one individual point only. The pulley is going to be getting stagnated, right? So what happens in this, once the conveyor, this belt is going to be moving, right? It is going to be moving to a forward and in this direction, in forward and backward direction, it is going to be moving. So on rollers, right? On a rollers, or either it is going to be attached or it is going to be moving, or either this base is going to be attached. One of the component is going to be attached and one of the component is going to be moving. So you have a rollers over here. So the bottom portion is going to be getting moved out. So what happens? The bottom portion which is going to be moving, it carries the waste, right? It carries the waste. When the waste comes, this is going to be continuously moving. These belts are going to be continuously moving in the direction, right? So what happens? Once the waste is being moved below the stationary magnet, it is going to be attached and the material is going to be thrown away as it is going to be moving. See, this is the momentary of the belt. So when it is moving, it has a magnet over here. Because of the electromagnetic attraction, it is going to be attracted. The ferrous materials are going to be attracted. Since it is moving away from the magnet, it is going to be released off and it is going to be falling. The other waste which doesn't have any ferrous materials are going to be kept in the surface itself only. So these are the two different methods which are going to be using for magnetic suppression, right? The one method was air suppression. The second method is our magnetic suppression, right? Okay. Then the third method is screening. Screening means what? We know that screening we have already done of sieving and all, sieve analysis we have done for waste, for coarse aggregate as well as fine aggregate, but we don't have something as a screening means separation, segregation, right? So what we do in this screening, it is the most common form of separation of the solid waste management. So it basically depends upon the size by use of one or more screening. See how we are going to be, you might have remember in the sieve analysis, what we are going to be doing in the sieve analysis, we are going to be putting the sieves of different size are put one above the other in descending order, right? This is the smallest sieve on the topmost corner, the coarser sieve on the topmost layer, then it goes on getting decreased. So the same way we are going to be doing the screening process. In this screening, either you can put only one sieve or different sieve based upon the number of separations which we are planning to do, right? It is the same as that of your sieve analysis, but the screening or amount of screening depends upon the characteristic property of the waste, right? So the screening has number of application in solid waste resources and energy recovery system, because see, when you are doing the segregation, when segregation is done on different types, so at different materials are going to be collected at different separation stages or different screens, so it becomes more easy to recycle and reuse. It further doesn't require, right? Once screening is done, like for example, if you are going for like the process which you have seen, the metal separation, magnetic separation, in while magnetic separation is done, you have every chances that the metal might be attached with some unwanted materials, right? Or let us say it is attached with the wet waste. So the wet waste is also being carried out along with the materials. But here it doesn't happen. So you have what you call refined segregation of the material based upon the sizes. So directly based upon the waste which are going to be recovered, they can either be used for resources or for any energy recovery systems, right? So screening are used before and after shredding, right? Shredding we have seen, we are going to crushing the material into different sizes, different grading we are going to be segregating. So that is what we are going to be doing. And after that, we are going to be using this for air separation. Either you can go for air separation, and both can be applied for lightweight as well as heavyweight fraction separation. See, here it is not so that you can be only using it for only light waste which is going to be light in weight. No, you can take any weight, you can just sieve it off, you can segregate them based upon the sizes. The sizes are decided based upon the waste size which is required to treat, right? So as I told you, it is only based upon the dimension of the sieves which we are going to be using for segregating the waste, right? Okay, this is how we are going to be doing the segregation process, right? A pictorial representation hopefully is going to be making you clear. So how we do this one? You have a feeder conveyor, right? So feeder conveyor, see, you can see the figure, right? You have a feeder conveyor, you have a wheel which is going to be driving the enclosures, which is going to be, see, you have a wheels, this are going to be rolling, right? Here you have the wheels, this wheel is going to be rolling our container, right? This is the outer cover. This outer cover is what we are going to be seeing over here. This is the outer cover you have. You have a screening drum, right? It is provided with different screens. This is what you are going to be seeing over here. This is the screen which is going to be provided. This, see, this is only a component, right? This complete component is led into a cover, right? Cover, so that this cover is not shown. The cover which you are seeing is not shown over here, right? It is only the screen over there. So what it does, the screen, this screen is going to be put in a cover, right? So remember, from one end, from this end, I'll be putting or I'll be feeding the material. This is inclined, right? This is inclined. It is at a higher elevation. It is at a lower elevation, so that it makes some angle. This is 5 degree of angle, which is going to be seen. Actually, it is 15 degree of angle, which is going to be showed over here, right? Okay. So it is led with some slope, so that, see, slope cannot be more, because what happens if slope is more? Let us say if instead of 15 degree, if I put it as 45 degree, what happens, right? The moment you put the material, because of the slope, all the material, you will not have sufficient time to get the separation. Here, time is required to separate the material. Again, one more thing you need to remember. The sieve dimensions, what you are going to be seeing, are going to be different. The opening dimensions, what you are going to be seeing here, they are going to be different from each chamber, right? Here, you might be having a coarse sieve. Here, the dimension of your, what you call it as, sieve openings are going to be getting decreased. So what happens? The coarser materials is going to be segregated at this point only, right? The material which is coarser in dimension is going to be segregated at this point. The material at the next finer is going to be segregated like this, right? So what happens? The complete material is made to travel, so that the moment it comes, all the material is going to be getting separated, right? So it has a shaft, a drying shaft, a drive shaft, which is going to be rotating the chamber. It is going to be rotating at some elevation, at some speed, which is going to be provided with the motor, right? With motor at one end. So what happens once we put or we feed, right? We are going to, how we are going to be working? This we have seen, the driving wheel, the cover, the drum, the thrust wheel, which is going to be helping in rotation, right? You have a cover, you have a drive collar, you have a waste deflectors. whatever the waste which is going to be removed of, this is going to be collected in the bottom. So it is going to be provided with an elevation, right? It is going to be provided with some inclination, sorry, not elevation, with some inclination based upon the type of waste. Inclination cannot be more, because if the inclination is more, the waste is going to be running at a far faster speed, so it doesn't give sufficient time for segregation. Please remember, in BMT lab or in CNHM lab, we have given some time for what you call it as sieving, whether you have to move in horizontal direction, vertical direction, up and down, in all the direction, because and for some duration of time, the time period what we are going to be giving is only with respect to make sure that all the material is going to be passing from all the sieves. Similarly, in the same way, we are giving sufficient time or sufficient slope, so that, or more flatter slope, so that more amount of time is going to be given for separation, right? So here you have the separate dimension of the sieves based upon the material. So how it works? Guys, you are in the class, right?
Yes, Mama, kude gele?
Mute yourself. I always say, let there be a disturbance in the class, but the disturbance should be with respect to the topic. Right? Just.